Okay, we do have just a few slides. We'll try to keep this fairly quick because I know you've looked at PowerPoint slides a lot. So my name is Natasha. I am the, there's a timer. Oh God. I'm the deputy coordinator for the applications program. Erin's the coordinator. And you heard a couple really good, important buzzwords in that little Menti activity. So we just want to talk a little bit more about this stuff. Maybe plant a few seeds depending on how many of you are really thinking about this stuff. I have a feeling that you're working on your research, you're working on dissertations, on theses, or whatever it may be, and maybe applications is not something you're thinking about. But maybe real quick, do any of you think primarily about applications, or not even primarily, but like reasonably about applications, or are you more focused on research? Applications, kind of? Okay, pretty good. So then maybe some of this will be familiar. But basically, not just applications, but communicating, the benefit to humanity, the benefit to society. In order to realize that benefit, again, being able to communicate. So, how can we share what we're doing in a simple and effective way? That's really kind of behind everything that we're talking about for the next few minutes, or for as long as we're here. So we're going to tell you about PACE Applications, about our program, why you should care, applied science, science communication, the impact, achieving greater impact of our science, what you can take away from this, a few models, a few best practices, and then we're going to have a little breakout activity for you to practice some science communication ideas after these slides. So yeah, the PACE Applications program is basically here so that when PACE is developing all of this incredible data, it's used, and it's used for greater impact for societal benefit. Everybody knows about it, not just in the scientific community, but the broader community. So we have 3 goals: addressing community needs, concerns, figuring out what those needs and concerns are, growing the relevance and the sustainability of PACE, demonstrating societal value and utility of PACE. So basically, we want people to use this data. We want them to know that it's out there, and we want them to connect it to society, to decision making, to policy, communication, public health, whatever it may be. So that's basically our job. Erin and I, communicate with people. We share the good word, as they say, about PACE. So some of these words that you've already heard, applications in particular, we say it all the time. We probably use that word 50 times, maybe every hour. But some people don't really know what an application is. It's not a computer app. It's not a cell phone app. It's the use of PACE data. So complementing, improving decision-making, providing practical solutions to meet societal needs. So the application of data. Applied research also. So we're not just doing basic research, we're trying to do applied research. So we're providing knowledge about PACE data so that we can integrate that into users' policy, business, management activities, and again, improving decision-making. So, and then when we're talking about end users, communities, stakeholders, we try to make this as broad a definition as we possibly can make it. So it could be individuals, it could be groups, it could be in the private sector, it could be in the public sector. Like Erin said, we're trying to think about how we can diversify. So who's in the private sector that could use PACE data? National organizations, international organizations, government, non-government, local and global scale. So we're trying to think as broadly as we possibly can. So we already mentioned the word accessible. So just so that we're all on the same page and you understand our priority about PACE data being accessible, usable, and actionable. What do these things mean? So accessible data is approachable, free of charge, understandable, unrestricted, machine readable. I think a lot of these things, and maybe in other words, were up on the screen, which is great. Usable data, basically it's going to meet the needs of different user audiences. It's ready for what they need to do with it, adapted to those user needs. And then actionable is basically in a form where it can already be acted upon. It can be used to inform decision making, and it's ready to be taken into those contexts. So these are all similar things, but making sure, again, that PACE data is not just going to stay in a model, but that it's going to be used to inform some decision. So you've probably inferred, or maybe you already know these things, but PACE is relevant for all sorts of applied science areas. NASA has 5 different applied science areas or thematic areas that you may have heard of, and now that I said 5, watch me forget them all. So climate, air quality, water, disasters, There's one more. Ecological forecasting. And yeah, so there's a lot of areas they overlap, as you can see here, and it's pretty cool that PACE, as you know, can support pretty much all of them in different ways. So it's very exciting that PACE is, kind of an Earth systems mission, which means that our applied science areas where we're relevant to speak toward those areas are very broad. So for us in the applications program, how are we working to achieve or try to get the rest of the team to achieve some of these things? We have all sorts of events that we want you all to be a part of, so take note. We have community listening sessions. We've had a listening session related to water resources, water quality. This year we had one related to air quality and applied atmospheric sciences. We've had kind of a survey or needs assessment related to terrestrial needs. We also have annual workshops. So the next slide you'll see where you can register for our annual workshop that's coming up. We also have a newsletter. So we have lots of different activities, again, where we're trying to figure out who is the PACE community, how can we expand that community, what do those community members need, really, and how do we get our team to help meet those needs. Okay, PACE Applications Workshop. If you haven't registered, this is our big annual, big glitzy, fun, huge event. We're hoping to have 1,000 people online with us for this virtual event. We have mission science updates. Jeremy's going to talk. You'll hear, I think Brian, I can't remember if you're talking. We'll have all of our PACE science team members talking, so you'll get the science updates, but I won't say more importantly, but in addition, we'll hear about applications. So we have a lot this year on co-production. If that's a word you're not familiar with, we'll talk about it in a second, but basically how do you work with your community members or work with your stakeholders to develop your research or develop your tools. Community engagement, mission synergies, so how PACE can be used alongside other NASA missions in applications and non-NASA missions as well. And then again, accessible tools, accessible data. We are doing, I was going to mention in a previous slide, now I remembered, the DAC that you just saw, some of those windows that are not quite as logical and intuitive as you might hope. We're working with our DAC to try to improve those. So we have our DAC representative, or one of the DAC representatives, on a panel where we're going to try to talk about what do users look for when they get on the OBDAC website. How can we make that tool more accessible to users, especially with PACE coming on board? There's going to be a lot of new users of the DAC, so how do we improve the experience for them? So please register. If you have questions or want to hear more about the workshop or want to be convinced to register, come talk to us. So one of the other big pieces of our programming is the early adopter program. We have a couple early adopters in the room, so I won't put you on the spot, but I should. Basically, the early adopter program is a way for us to get PACE simulated data at this stage, or get the idea of PACE into the hands of applied users in the research community. So we want to get people using PACE data, aware of PACE, kind of considering how they can incorporate it into their work pre-launch, so that post-launch we already have a community of people that are using PACE data. So we collect feedback, we share your work, we do a lot of things with our early adopters, and we're always looking for more early adopters. So it may be tricky as students, if those of you who are students, but if you have an applied use of PACE data and want to think about the early adopters program, we encourage you, take a look on our website and consider applying. So just so you're aware, we have early adopters across different sectors. We're mostly in the academic space, which makes sense given kind of the heavy focus on research, especially with this pre-launch stage. But we do represent other sectors. We also represent all the different thematic areas. Makes sense, about half of our early adopters are in water resources, but we're trying to increase the other sectors to be better represented. So our air quality representation is growing, climate, eco-forecasting, we're definitely trying to expand all of those non-water areas to make sure we're thinking about all of the potential uses of PACE. So you can see the lovely faces of our early adopters. We have 26 at the moment. The green boxes are our water users. The blue are our air, and I think the yellow and orange are kind of other terrestrial, climate, other areas. So just to give you a sense, I'll just highlight two early adopters real quick. Some of you may know Rick Stump, but he and his team are doing work on using hyperspectral data for looking at harmful algal blooms in inland lakes, coastal beaches, estuarine environments. So what's unique about early adopters is that they already have stakeholders. So you could see on the bottom of the screen that they're working with all sorts of stakeholders: state managers, health departments, water treatment operations, agriculture, commercial fisheries. So that's a requirement of our early adopters, is that you have your own stakeholders and end users who are thinking about how they could incorporate maybe model outputs or whatever it is. More on the air quality and atmosphere side, Marcella is an early adopter out of the University of Oklahoma. She's doing improved smoke forecasting, linking that to health alerts related to pollen, dust, smoke. And again, she's working with stakeholders as well in Oklahoma Mesonet Fire Network, Oklahoma Air Quality Division, and using PACE to advance some of her air quality models. So we're trying to really emphasize here that effective user engagement, co-production, is going to get better, practical, useful, impactful science. So what does this look like in practice? This is a lot of words, which hopefully you can see. This is taken from the NASA Applied Science Handbook, which was just released recently. Basically, this is, some ideas of how and when you can be incorporating your stakeholders' feedback, working with stakeholders. So everything from building relationships, whether that's eating crabs together, beer, whatever it may be. I took out a group that was new to the U.S. once to Ethiopian food, and there's no better way to make friends than eating with your hands. So building relationships can take many forms. So on, what is that, the left side, I think for you all, whatever. On this side, those are kind of people-centered ways that you could be building relationships and working with stakeholders. On this other side, or how to incorporate that into your science. So you're building relationships, but the point of that is so that you can hear those needs and think about how you can fill those needs with the work that you're doing, all the way down to engaging with those users, using that feedback to create your concept and formalize your concept, as well as modifying and adapting when you need to. You're moving on to development and testing. You're collaborating more, prioritizing their needs, again, iterating based on how you can meet those needs, moving to building capacity. Capacity development, capacity building is a huge part of working with your community so that they can actually use what it is you're developing, operationalizing your application, and then looking for new opportunities as well, constantly staying in touch. If you have a strong relationship, there's always new ideas, there's always new opportunities. So that may look like publishing papers, that may look like even gray literature, blog posts, getting your work kind of out of that ivory tower and more into, new eyes, new perspectives, getting more people to know about what you're doing. So NASA cares about this too. If you've ever seen the ARL levels, the application readiness levels, are any of you familiar with these? If you've done NASA grants or NASA work? Okay, so this is huge. So I think you had a session or something about grant writing earlier in the week. So kind of. Woody, I think Woody was here. So if any of you are possibly thinking about applying for NASA work in the future, or even if not, this is an important way that you could kind of think about how you're formalizing user engagement and society kind of decision making into your work. Co-production, how you're co-producing your work with your end users. So a lot of NASA grants require certain ARL levels in order for you to even apply. So that's why it's good for you to be aware of this. So starting with basic research, but moving all the way into deployment and getting your work into the hands of decision makers. That top phase, that phase 3, is the hardest, obviously. There's not that many projects that have done it successfully and that maintain that level of engagement with their end users. So it's important that you start from the very bottom. It's not enough to just do some research and then say, hey, does this work for you? You want to be co-producing the idea of your research from the very beginning. So it's important to note that NASA cares about this too, not just for funding, but just, again, for the sustained relevance of your work, impact, societal benefit. So just so that you're aware, we've got all sorts of resources on the PACE Applications website. We have links at the end for you to take a look at. Anything else we want to say about our website? There's stuff on here about the Early Adopters Program, more about our events, more about applications. Okay, tried to go fairly quickly through those slides. Before we do our activity, any questions, any comments, any thoughts, applications, accessible data, co-production? Yeah?
Is there anything you would recommend in terms of finding stakeholders?
Yeah, that's probably the biggest question. And I think there's a million things that you can do. Number one is kind of getting into their environment. So that's kind of what we mentioned about some of these conferences that are not quite as science heavy. There's a lot of conferences that have different focus areas, if it's like indigenous and tribal priorities, if it's like regulators like EPA, if it's community level, I don't know, emergency management, fisheries. There's different venues like that you can just kind of go and introduce yourself, get to know people. Universities also have a lot of really good applied kind of centers where this is happening, so you can connect with researchers there. What do you think?
How I did it is I was, a first-year PhD student developing algorithms for ocean color, and I needed field data, and I needed to get on a boat, so I called up the Chesapeake Bay Foundation. What better stakeholder? At the time, I thought I was just going on boats to take water samples, but in reality, I was making a relationship with a operational agency that feeds data into NOAA for forecasting. So get creative. Just kind of get out of the typical academic bubble of who you're talking to. And not just for your research, but for your network. Had I not gone on that boat in the Chesapeake Bay 12 years ago, I would not be in this job.
And there's nothing wrong. We talk a lot about cold calling, and there's even, I don't think Cecile was a part of this course, but I love the story. Cecile now is, as staff, a NASA employee in the lab, and she got to where she is because similar, I don't know how long ago it was, 10 years ago, she was a grad student, and she found a bug in some data that NASA was producing somewhere, and she sent an email just to say, hey, I think I found a bug in your model or something. And from there, it started a whole trajectory of, oh, who are you? We want to talk to you. What are you doing? And now she works at NASA. So she always loves to tell that story too. So cold emails are fine. Just just do a Google search, and if you see an organization where maybe they're interested in what you're doing, send them an email. But it's important to say, okay, this is what I'm doing. Who cares about this? And who is this relevant? Who is this relevant for whom is this relevant? Maybe I should say that. So yeah, thinking that way, but the fact that you're asking that question is great. Oh, yeah.
What is the starting readiness level in general for NASA's proposal?
It depends. The starting ARL?
Yeah, for if you apply for anything under Rose's Applied Sciences, your proposal probably will not make it through the first round if you're not above a 4. I've been on Applied Sciences panels, and they basically tell reviewers if it's a 3 or lower, don't.
And what is the aim readiness level for those proposals?
I'm sorry, what's that?
The aim. We have a start readiness level and also aim.
Ideally, they want you to get all the way up to that 7 to 9. But like Natasha said, that's difficult. There's a bunch of us here that are involved in projects that have tried to get to 9, and it takes years. And these are people at, these are PIs at federal agencies that developing and handing off your tool and sustaining use in your decision makers' framework.
Erin,
Yeah.
don't a lot of Rose's calls have applications as a piece of the call? So it's not purely applications, right?
I don't actually
I think it depends. Well, and even with the ARL, they'll often, not all the time, but they'll say, we're looking for ARL here. We want you to get here by the end of the project. How will you do that? And your proposal has to say. And I think sometimes there are proposals that are application based. And then there are other proposals or solicitations that are validation based, and it's not, they don't really care as much about the application. It's not relevant.
Right.
So it depends. But it should be clearly noted, the type of solicitation.
So for the PACE science applications team, what he did actually put some money into.
Right.
So
We have 3. Yeah.
But there weren't that many application
Right.
proposals submitted. So it is something, if you have an interesting or good application, it's definitely something to look at because there's a lot of scope there to
Yeah.
get funded.
But as far understand, in addition to having like that level 3 or 4, you also have to have letters from your stakeholder showing and demonstrating that partnership to get basically your proposal considered. So,
But at the same, oh, sorry, go ahead.
It's kind of like letter of support, right?
Right.
yeah.
Yeah, but at the same time, a letter of support is not enough. So I've seen projects where they write to a community organization and they say, hey, we're going to make this product. Do you think this is cool? And so they'll have a letter saying, yeah, this is a cool project, but there was no effort in the proposal about how that team worked with that community organization to develop the project together, to co-produce that idea. So the letter is supposed to just be some sort of like piece of evidence as to the relationship. So the co-production piece and that application concept, working with the community, and it's not clear enough in the ARLs when the community involvement and stakeholder engagement and user involvement should happen, but it should happen very, very early on. And it's pretty clear in proposals when that hasn't happened, and reviewers look for that.
All right, we have 20 minutes.
Oh,
We're
yeah.
gonna have to do this fast. All right, so we're gonna do a little activity, and the reason it made me think of the very first question when I had my dissertation qualifying exam, and the very first question my committee member asked was, if you were on the Chesapeake Bay, which is where my research was, and you were talking to a manager who's out there on a boat, and they basically asked you about your research and how it impacted them, go, 2 minutes. So that's what we want you guys to do. I know a lot of you guys are working on basic research, but I want you to break into groups. You'll have 2 minutes each to basically pitch why your research is important and how it directly impacts an environmental manager. The other 4 of you in the group are the environmental manager. You are very skeptical. You think that, basically you're talking to a scientist and you don't understand anything that's coming out of their mouth. So this is both a practice in science communication, but also really thinking about how does your research, if you're developing an algorithm, how is it, all the steps, how is it going to impact the environmental manager on the Chesapeake Bay? And so things to consider: what are the manager's needs and goals? So that's basic science communication. Think about your audience. How is it going to impact, that could be positive or negative, their work? And then how are they ultimately going to apply the output of your research, whether that be directly or indirectly? So can we count off, I think there's 41 students. If we count off 1 through 8, I don't know where we want to start. Whoever's a student, you guys want to start? 1, 2, 3, 4, 5, 6, 8,
1, 2,
3, 4, 5, 6, 7, 8, 1, 2, 3, 4, 5, 6, 7, 8, 1, 2, 3, 4, 5, 6, 7, 8, 1, 2, 3, 4, 5, 6, 7, 8, 1, 2, 3, 4, 5, 6, 7, 8, 1, 2, 3, 4, 5, 6, 7, 8, 1, 2, 3, 4, 5, 6, 7, 8, 1, 2, 3, 4, 5, 6, 7, 8, 1, 2, 3, 4, 5, 6, 7, 8, 1, 2, 3, 4, 5, 6, 7, 8, 1, 2, 3, 4, 5, 6, 7, 8, 1, 2, 3, 4, 5, 6, 7, 8, 1, 2, 3, 4, 5, 6, 7, 8, 1, 2, 3, 4, 5, 6, 7, 8, 1, 2, 3, 4, 5, 6, 7, 8, 1, 2, 3, 4, 5, 6, 7, 8, 1
1, 4, 8, 2, 3, 5,
All right.
It's pretty good.
You guys are all smart people. Remember your number. There should be 5 of you in each group. So 2 minutes each, 15 minutes. We'll come around and check. Nominate your favorite. One person from each group is going to